Let's determine the points of inflection and discuss the concavity of the graph of f of x equals x to the fourth. What? Why do you start out so complicated and then get so incredibly simple? I don't know. Maybe this is a special case or something. I don't know. Let's take a look. So I need to find the second derivative so that we can find the potential points of inflection, or supercritical numbers. So let's take our derivative here. F prime of x is equal to 4x to the third. Easy. Second derivative, 12x squared. Okay, so is this thing ever equal to 0? Sure, at 0. So x equals 0 is our possible point of inflection. In order to see if it is a point of inflection, we have to see if the second derivative changes signs. Does our graph change concavity to either side of x equals 0? In order to see, I'm going to do a test for concavity with a sign chart. Now, as far as this goes, we need some intervals. Since this is a polynomial function, its domain is all reals. So we're going to break up from negative infinity to positive infinity right there at 0. Intervals. Intervals. Okay, there we go. I spelled it correctly, I think. From negative infinity to 0, and from 0 to infinity. Okay. Test values? How about negative 1? How about a positive 1? Where are these going to go? Since we're testing for concavity, it's going into the second derivative. So our second derivative, hey, notice that we have a squared there. It doesn't matter if we stick in a negative or a positive. This thing is always going to be a positive number. What the heck? All right, so this is going to save me some time. This is a plus and a plus, which means to either side, this is concave up. It is also concave up. Since it does not change signs, it being the second derivative, since the second derivative does not change signs, since the function f does not change concavities, there is no point of inflection at x equals 0. So x equals 0 is not a point of inflection because, let's see, f does not change concavities. Change concavity. I can justify like that. I can also say that, or f a double prime of x does not change signs. At x equals 0. Right? Okay, so what does it mean? Does it mean that it's concave up here, concave up on the other side of it, but not at 0? Let's take a look at the graph, shall we? Okay, so that's the wrong graph. This is the correct graph. So here's f of x, just kind of a flat-bottomed parabola kind of shape there. Let's look at the second derivative, and we can say second derivative is equal to 0 at 0. And over here on the left-hand side, so it's positive, so it's concave up. The second derivative is positive on the right side of 0. It's concave up, but what about 0? Well, if we were to draw in a tangent line right here at 0, that tangent line would be below the graph. And since it's below the graph, then that means at 0, it's actually concave up as well. So this is concave up everywhere. It's concave up everywhere for the whole entire graph. And we can say that is true because the second derivative is greater than 0 for all values of x that are not 0. And we do have a tangent line, a horizontal tangent line right there at 0, and that tangent line is below the graph. Therefore, it is concave up everywhere.